Assalamu alaikum YouTubers, welcome back to SLK Tours. Today our topic is about the mean area method, and using the mean area method we'll be learning the earthwork calculation for an embankment. Let's see how does the mean area method work. Say we are just asked to work out the quantity of earthwork per an embankment 150 meter long and 10 meter wide at the top. Side slope is just 2:1 and the depths at each 30-meter interval are also given. I think the data is quite enough to calculate the earthwork, so I'll come straight to our here solutions. But before starting the calculation, let me show you the embankment picture like this one. The top is just 10 meter wide and the side slopes are 2:1. Remember, my approach is only the earthwork or the quantity of this trapezoidal shaped soil, right? Let me draw the same section over here, this one, and remember I'll just complete my approach using the mean area method, and the mean area method can be done in this simple table, right? The first column will represent the stations, the next will represent the depth at each 30-meter interval which are given, and then I'll calculate the central area, which is of course just the center of this trapezoidal shape, right? And then the area of triangular shapes at both sides, which is of course SD square, because the slope is just uniform to both sides. Remember, if the slope is not uniform to both sides, then the formula can be written in form like SD square divided by 2 per one side and SD square divided by 2 per another side. This time the slopes are just the same at the both sides, so I'll use only SD square. This is a simple formula, right? And then we'll just add column 3 and 4, which is the total area of this section. When we have the total area, then of course we can calculate the mean area. And the 7th column will just represent the interval and then the quantity of earthwork in form of cut or fill. If you just look to the example terms, we have 30-meter interval up to 150 meter. So the station must be from 1 to 150, like 0, 30, 60, 90, 120 and 150. Remember, the depths at each 30-meter interval are also given, say 0.60, 1.2, 1.4, 1.6, 1.4 again, and 1.6 again at 150 meter. Now, of course, I can calculate the central area, right, which is just like a rectangle BD. The breadth is given 10 meter, and the depth at each 30-meter interval are also given. So I'll just multiply the depth with the breadth or the breadth with the depth, no problem. If you need to calculate the central area per station 0, we'll just multiply 0.6 with 10. So 10 times 0.6, we can get 6 square meter as the central area at station 0. I'll plug this video over here, right? Now, if you need to calculate the central area at station 30 meter, of course, we need to multiply 1.2 with 10. We can get 12 square meter. I'll plug this value over here too. And then per change of 60 meter, we have of course 10 times 1.4, which is 14 square meter. And do the same for all these three remaining guys. In the fourth column, we need the sides area. And the sides are just triangles. Remember, we have a nice formula SD square. So I'll plug in again in this equation, right? Like if you see SD square, and I need to calculate the sides area for station 0. So S, which is 2, remember I'll take only the 2 times D square, the depth at station 0 is given, which is 0.6. So 0.6 square, we can get of course 0.72 square meter. I'll plug this value over here in the second row. Now I need to calculate the sides area for station 30 meter. The formula will be the same as D square. So S is just 2, which is 2:1 times D square. The depth over here is just 1.2. So 1.2 square, we can get of course 2.88 square meter. I'll plug this value over here in the third row. And now per 60 meter change, we have of course 2 times, the 2 is just the side slope, 1.4 square, because 1.4 is just the depth at 60 meter interval. We can get of course 3.92 square meter. I'll just plug this value over here in this table. and do the same method for all these remaining guys. In the fifth column, we need the total area, right? The total area is just a summation of central area and sides area. So 6 plus 0.72, we get 6.72 square meter. And 12 plus 2.88, we can get 14.88. 14 plus 3.92, we can get 17.92. 16 plus 5.12, we can get 21.12. 14 plus 3.92, again it is just 17.92, and again 16 plus 5.12, we can get 21.12. Now the mean area calculation is quite simple. We'll just add two areas and divide them by 2. This is called the mean area, right? And that's why we call this method as a mean area method. Now for example, I just need to calculate the mean area of station 0 and station 30 meter. I'll just add 6.72 and 14.88 and divide these two guys by 2. I can get, of course, the mean area. For example, 6.72 plus 14.88 divided by 2, we can get 10.8 square meter. And this is, of course, the mean area of first two stations, like station 0 and station 30. So I'll plug this value over here in this column, right? And then the mean area for station 30 and station 60, we can of course add all these two guys and divide them by 2. So 14.88 plus 17.92 divided by 2, we can get 16.4 square meter. I'll also plug this value over here in this table. And for third and fourth station, we'll add all these two guys and divide them by 2. We can get of course 19.52 and do the same for the remaining guys. Now what are the intervals? Look at just the example terms. Interval is just 30 meter. So I'll just put 30 meter in this column, right, for all these stations. 30 meter, 30 meter, 30 meter, and so on. Now remember, the quantity means the volume. And the volume is always the cross-section area times the length. Now remember, we have of course the mean area in the interval, so I'll multiply the mean area with the interval. Of course we can get the quantity in form of cut or pill. So 10.8 times 30, we can get of course 3 to 4 cubic meter is earthwork between 0 and 30 station. Why I put this value in the filling? Because it is just an embankment, remember? And 16.4 times 30, we can get 492. 19.52 times 30, we can get 585.6. Cubic meter is spelling. And 19.52 times 30 again. And these three guys are of course the same. So I'll just plug the videos, right? Now if you add all these guys, like from station 30 to station 150, we can get of course the total filling or in embankment quantity equals 2572.8 cubic meter. And this is how we work out the quantity of earthwork per an embankment. And this is quite simple, I think. Nothing is just complicated, right? If you have any question, you can of course type in a comment. Thank you guys for watching. See you next time, and wassalam.